So if we want to model our windows more accurately, more in line with the certified passive house procedures where we're supposed to input things like center of glass U value and frame U value separately, how are we gonna do that here? How can we enter all of that information? And as I showed, using the native Honeybee tools and using the standard Energy Plus methods, we can't. That's not how Energy Plus, Open Studio, or Honeybee work. Right? They're different modeling tools than the PHPP. So we have to use some of our new Passive House tools, LadybugTools to PH plugin components in order to do that. So I'm going to come up here to my PH Tools ribbon. So I'm in my Grasshopper definition where we just added our new window construction and window materials to the scene here. And I'm going to come up here to my Passive House Tools ribbon, and I'm going to come over to O1 Model. And notice at the top here, the top section here, we have a whole bunch of components that seem to have to do with windows. So we have create PHPP aperture, we have create PHPP window glazing, and we have create PHPP window frame. So we've got a couple of different components here that seem like they're going to allow us to do some window modeling. And indeed, that's exactly what they are for. So in order to create these PHPP style windows, we have to use some of these new Passive House Tools plugin components. So the first thing that I want to do is I want to use this create PHPP aperture component. So let me click this and drop it onto the canvas here. So this component is what's going to allow us to build our PHPP style window apertures, where we've got the glass and the frames and the side values all broken out separately. So let me zoom in here and let's take a look at what type of at what we need for this component. So first of all, we have an input here for apertures. So this component is going to take in one or more Honeybee aperture. So the apertures from Honeybee, after they've been created, get input into this component. And then notice we have the ability to input frames, glazings, and something called installs separately. So we have the ability here to break out the different component pieces more in line with our PHPP expectation. And indeed, we're going to input all of the information here in exactly the fashion that you would expect for PHPP. Notice the output are apertures. So the output of this component are also apertures. And so this takes in apertures, performs a series of modifications, adds a whole bunch of stuff in the background, and then kicks out apertures, which can then get folded in with all your normal Honeybee modeling just as before. So this guy sort of gets used in line with our other Honeybee components. And it just adds a bunch of new information and functionality to those Honeybee objects. Okay, so let's see how we might use that. So I have my, let me pull this off to the side. So these are our Honeybee materials. So I have my aperture geometry. I have my Honeybee apertures, which are being created. And this component, remember this PHPP component, wants to take in those Honeybee apertures after they've been created. So I first create the Honeybee apertures, and those Honeybee apertures are going to feed into this PHPP aperture component. And notice by default, this guy kicks out a series of apertures as well. And so we take in a series of apertures and we kick out a series of apertures. So by default, we could just slide this right in. So let's do this. Let me move these over. And I'll put this guy right in line here. And as I said, after this component has added a whole bunch of new features and functionality to our Honeybee objects, we just take the output apertures and just feed them into the rest of our script. So I'm going to feed this into the sub faces here, and then that's going to flow through the rest of my Grasshopper definition. Now, if we were to go back and take a look at our PHPP right now, we would not see any difference. So far, everything looks the same. So nothing changed. Adds custom window, go to components, adds custom window, 1.34, 1.34. Where'd the 1.34 come from? That was our U value that we supplied here. It adds custom material. So far, this hasn't done anything. Well, and that's because we haven't taken in any information. So we have not input any frames, any glazings, any installs. So by default, if you don't input any information, it's not gonna do anything for you. So let's add some information to this. Let's set some custom glazing. Let's set our own custom glazing here. So we're going to input some custom PHP glazing into our glazings input. So let me kind of pull this down a little bit so that we can see that a little more easily. And let me come up here to my Passive House Tools and O1 Model. And in O1 Model, I'm going to come down to Create PHP Window Glazing. So you can see the little glass icon there, and let's click and drop that onto the scene. And let's see what we have here. New PHP glazing. We'll combine parameters together, create a PHP glazing object, connect it to the PHP Apertures component. So here's our PHP Apertures component. We've got our glazing, and it takes in glazing. So what is this guy going to do by default? Let's just take a look at what the default is. Nothing. So we don't get anything by default. So this doesn't do anything until you give it some information. All right. So let's call this eds PHP glazing. And let's give it that as a name. And notice as soon as I give it a name, we now get a glazing object out as a result. A PHP style glazing object. And if we want to see the parameters, we can just use this out to see what parameters have been set. And by default, this component is going to create a glazing with a U value of 1 and a G value of 0.4. Now, of course, we can control those by just entering a different value here for my U value or my G value. And notice here that the hint is letting us know that for Passive House projects, the glazing center of glass U value is supposed to be calculated as per EN 673. So what we should be doing with all of our projects is getting an actual glazing submittal from our supplier. So let me pull up a sample, an example. So here is a Calluman report for a specific type of glazing that might be common for cold climate Passive House projects. 4mm glazing, 16mm argon fill, triple glazed. It's got some low E coatings, which give it a pretty darn good U value, a UG value of 0.5. So this is a good value. And notice it's as per ISO 10292, which is also it's basically the equivalent of EN 673. And then notice also over here on the right, we have our solar factor, our G value of 37%. There's a whole bunch of other stuff here, but this doesn't really matter for PHP purposes, so we can ignore almost all of this. There's just these two little bits of information that we are interested in. So maybe instead, let's call this what's this? This is this single main, Climatop 1. So Climatop 1. So maybe instead of eds PHP, let's properly call this SGG Climatop 1. So that's the actual type of glazing. And that was, what did we say? 0.5 for the U value and 37% for the solar factor. So let's come over here and let's put in 0.5. And this is going to be in, just to make it clear, watts per square meter Kelvin. And that'll be our U value. Notice as soon as I input that, our U value changes over there. And G value is 0.37. So 0.37. And that will be our G value, and that's just a percentage. So that's just, percentage value. All right, so 0.37 G value, 0.5 U value. In order to use this glazing on our project, all I need to do is take this glazing and input it into the glazing input of my PHP Aperture. And as soon as that's done updating everything, delete this, as soon as that's done updating everything, that data now flows through my entire model into the add subsurface, into the room, into the model, etc., and out to the PHP. So if I go to my PHP now, notice my new glazing has been updated to the SGG Climatop 1 with a 0.37 G value and a 0.5 watts per meter squared degree Kelvin U value. And of course, that has also been applied to the windows themselves. So notice those windows now all have that Climatop 1 glazing applied to them. Notice though that they're still using Ed's custom window for the frame. The frame is still set to 1.34. So that component that we just built only sets the glazing, right? So this guy only sets up the glazing for a window. We can set up our frames by using a different component. So if I come back up here to my Passive House Tools and I come to Model and I come to Create Window Frame, so Create PHP Window Frame, I can drop that onto the canvas here. And so we've got our new component here, our new window frame component. Let me pull this over and let's take a look at the inputs here. So this is very similar. We're going to take in a bunch of information and we're going to kick out something called a PHP frame. Let's take a look at what we get by default. We get nothing. Okay, so, and just like before, as soon as we give this a name, so let's call this as PHP custom frame. Just as with before, as soon as we give this a name, we should get a default construction. So there we go. As soon as we give it a name, we get a default construction, PHP style frame object, adds PHP custom frame. And if we want to see the parameters, we can connect it up to this out. And notice that a whole bunch of values have been set, things like the U value for the left, the U value for the right, U value for the bottom, the top, the frame width for the left, the right, the bottom, the top. Ooh, that's a lot of information. Well, remember, go back to our PHP for a second. When it comes to frames in the PHP, we are expected to input left, right, bottom, and top U values, frame widths, sci value glazing edges, and sci install values for our each frame type. It's a lot of data for one frame element or one frame type. But the reality is that often the values are different than one another. The heads or sides or sills are different sizes and have different U values, different components, pieces, different materials, etc. So a lot of information here. They're not always different, but often they are different than one another. So okay, so we have to put in a lot of information here. By default, of course, it's going to build this default frame for us. So that's great. So okay, so what can we input here? Well, we can input a series of window widths. If I hover over this and we look at the tooltip here, it says input values for the face widths of the frames. Input the values as a list in the order left, right, bottom, top. If less than 4 values are used, the first value will be used for all 4 edges. Okay, we'll come back and take a look at that. Frame U values, same thing, a list of values calculated as per 10.0772. Input values in left, right, bottom, top. If less than 4 values are input, the first value will be used for all 4 edges. Side glazing edges, these are the thermal bridges associated with the spacers. And then side installs for your individual window elements as well. Okay, so an awful lot of information here. Of course, a lot of it is going to be by default unless we explicitly override it. So let's set up some frame widths. And let's use an actual window frame product. So let me pull up a sample here. Let's use this guy. So let's say that for our project here, we're going to use these window frames right here. It's a typical cold climate, high performance window frame that we might use on a high quality passive house project. Wood frame elements with an aluminum cladding on the exterior. Notice it's nice and deep, and it's got at least 3 layers of gasketing for air tightness. And we'll see in a minute, this has a very good thermal performance, very low U values. So this is a really high quality, excellent window product. This is an OptiWin product, and you can see the certificate here. I just downloaded this from the database, the PHI maintains, so the online database that PHI maintains. So let me just scroll down a bit. So this is all fine. That's all fine and dandy. Here's the piece that we want. So this is what we're interested in for our purposes. Here we see the face frame widths, top, side, bottom, and the U values, top, side, and bottom. And notice they're mostly all the same, except that the bottom has a different U value. We also have our psi value for the panel edge here. So, okay, so we need to input this information. So let's start with the width. So the widths are all 0.92, so 92 millimeters. So I could come in here, and right now, notice that the face frame width is set to 100 millimeters, or 0.1 meters. So we need to set that to 92 millimeters, so 0.092. So we could do it that way. And if I input that into the frame widths, notice that all of my frame widths got reset to 0.092. Now I could also say 92 millimeters. That would also do that. And notice the readout here is giving us a warning. It's saying, oh, I noticed that you put in a unit there. I'm going to convert 92 millimeters over to meters using this conversion factor. And so I end up with 0.092. So you can always put in the units that you want there. I should note you could also put in something like, 4 inches. Say OK, and notice that it'll do that same conversion for 4 inches, set it to 100 millimeters. So you can input those types of units wherever you want. In our case, let's say 92 millimeters. I'll say OK for our frame widths. And remember, if we only input a single, this is expecting us to input values in a left, right, top, or bottom, top order. So by default, this thing is expecting us to input a multi-line and to input left, right, bottom, and top order. And notice it's going to set those accordingly: left, right, bottom, and top. But as the help hint said, if I only input a single value, then that value gets used for all 4 edges. So while we can explicitly input the individual items for all 4 edges, we don't have to. We could input just a single data point, and that gets applied to all 4 edges. So let me do that there, and we'll make this not multi-line data. So that's just a single piece of data, and it gets applied to all 4 of those. Okay, so there's our widths. Let me bring back our certificate there. Let's input our frame U values. So let me bring back the certificate. So our frame U values. Well, here we have a difference between the top, the sides, and the bottom. So 0.76 and 0.94 watts per meter squared degree Kelvin. So 0.76 and 0.94. All right, so 0.76. So if I was to input 0.76 as the U value, notice that that U value gets applied to all the left, right, bottom, and top. And so in this case, I actually do need to make this a multi-line input. I need to input the left, the right, the bottom, and the top. Did I do that right? Let me go back to our certificate. The top is 0.76, the sides, the left and right, are 0.76, and the bottom is 0.94, and that's how we have it here. And so as soon as I input that guy, notice over here, the left is 0.76, the right is 0.76, the bottom is 0.94, and the top is 0.76. So sometimes you have to input information as a list. Sometimes you can get away with just a single input. It depends on the frame, depends on the element that you're using. All right, what about the last one here? The side glazing edge, 0.023 watts per meter Kelvin. Okay, and they were all the same, right? If I go back here, 0.23, 0.023, 0.023. Good. Okay, so they're all the same. We don't have we won't deal with mullions just yet. So let me just do this, and let's say 0.023. And let me input that as the side glazing edge. I could set this as a list of 4. That would be fine. But again, because they're all the same, I can just input a single data point, and that gets applied to all my side left, right, bottom, and top. Now, I don't think I yet have a SCI install for this, so let's just leave it set to the default for the moment. We can always come back and add our SCI installs once we've done our thermal bridge calculations. That would be just fine. But for now, let's just leave it set to the default 0.04. That's a reasonable value for kind of wood construction, that sort of thing. So fine. So let's leave that set as it is for now, and then let's apply this frame. Well, I guess I should change the name too. What was the? Let's use the right name. OptiWin Purista. All right, fine. So we'll call this OptiWin Purista. 0.76. That's a darn good frame. Anyway, so let's apply this OptiWin Purista to our project here. So all I need to do is take this frame output and apply it to my apertures. So frame gets connected to frames. This gets applied and this will flow through. So this is updating all of our windows. It's going to flow through our subsurface into our rooms, etc. And let's go take a look at our PHPP, which has now been updated with the OptiWin Purista 0.76, 0.94, 0.092 meters for all the face widths, 0.023 for all my glazing edges. And if I go to my windows, notice now all my windows have the OptiWin Purista frame applied, and my single pane Climatop 1 applied as the glazing. So that is an alternate method. I can, at this point, get rid of my custom material here because that's not actually being used for anything anymore. So I'll delete that, and this will update and calculate through. We are now using a set of custom-made glazing and frame objects in order to control, to a very high level of detail, all of our PHPP inputs. And at any time, of course, I can come in and change any of these values, and that will update in the corresponding location or the corresponding spot inside of our PHPP. So if I need to change or update any of these values, it's as simple as coming in here and making that modification. So hopefully that made sense. Hopefully that is all working for you. However, you can see what's beginning to happen here. It's already starting. I'm starting to get an awful lot of components and a lot of pieces. And so while this method is useful, and while, these components exist and you can use them at any time you want, I prefer to enter this information in a different way. And so when we come back in the next video, I'll show you another method for entering all of this information, and we'll look back at the Rhino side tool, and we'll look at some components that we have built in there and some catalog commands and tools that we've got built in there to allow you to do all this information and parameter assignment back in the Rhino side tool. So I'll see you back in the next video, and we'll take a look at those new tools.